Hi guys, thank you for tuning in. This is a Macaulay slope and deflection. The question goes like this: a beam of length 6 meters. 6 meters is simply supported at its end and carries 2-point load of 48 kilonewtons and 40 kilonewtons at a distance of 1 meter, 3 meters respectively from left support. Determine the deflection under each load. Take E to be 2 and I to be 85. Yes, so this is the beam. It is simply supported beam. Okay, it has 48 kilonewtons at a distance of 1 meter from end A and 40 kilonewtons at a distance of 3 meters from A, and then a span of 6 meters. Now the first thing we do, we determine reaction. We determine what? Reaction. Determine for the reaction RA at RA. This is the procedure. The first thing how to tackle this question, we do reaction first. We get reaction A and a reaction B. Okay, so these arrows that point this way, we normally call them reaction, and these arrows that point downward, they are called action, or sometimes we call them action forces, because action forces and we have reaction forces, they must be equal. Okay, that's the concept behind this. The action forces and the reaction forces must be equal. Okay, if this one is 80, if action forces are 8, it is 80 kilonewtons, then the reaction must be also be 80 kilonewtons. Okay, then so reaction A plus reaction B, it must be equals what? This action forces. Now when we add this one, 48 plus 40, it is 88. So you must also place in your mind that the reaction A and reaction B must also add 88. Okay, now taking moment at A. When you take moment at A, we start from this side. When you say reaction B times span, all span, which is 6, minus 40 times its span, which is 3, minus 48 times its span, which is 1, is equal to 0. Okay, then times RB times this one is equal to 6 RB. All of this will be 168. When you go to this other side, it becomes 168. Then 168 over 6, 28. Then 28 minus from 88, we got 60. So RA is 60 kilonewtons, RB 28 kilonewtons. Okay, yes. Now after that, now we come to the next point. So this is the first one. We get the reaction. Of the reaction, we go to this part. Consider section X in the first part of the beam at a distance of X from the right support B. Okay, so I've just put something here. We consider this a section of X. So we put X here between A and C. We just cut this, we put this one so that we can work out this part easily. Okay, yes, this is reaction A, this is C, this is D, this is B. Okay, now the bending moment at section X is given by this is a general formula. Okay, EI dy d square y over dx square. We quote it with the equation that we got. Then we take 28 reaction B, which is 28 times X, which X, this distance here from here, we call it X, times X minus 40, which is for this 40 minus 40 is close bracket X, this 40 up to this part, it is x minus 3 from here up to this part, x minus 3. Okay, I'm trying to alert for you to view it very well. Okay, yes, so this 40, it is this 40 close bracket x minus 3 from here up to this section that I cut. It is x minus 3 minus 48, which is 48, this one, x minus 5 from here up to here. It is x minus 5. Okay, so this is the okay, let's go. Now we have gotten this one. Okay, let's continue. After that, we come to this part now. Now we integrate this one. We integrate this one 2 times. We integrate it 2 times. So integrating the equation above, we got this one. I think everybody knows how to integrate it. So we integrate this one so that we can get this one. Okay, after integrating, even this one changes. It was d square y. Now it will remain 1d. X will also remain 1, and this part become 2. It was 1 2. Now over 2 again, we introduce this one. The first integration, we introduce c1. At the first integration, we introduce c1 minus 40 is equal to this one. This 2 was not there. It was 1, so we add 1. It become 2 over 2 again. Minus 48 is equal to this x minus 5. The 2 was not there. It was 1. We add 1 to it become 2 over 2 again. This one is the first integration. We get this one. We got this. Okay. After getting this one, again we integrate again. Second integration. This one is the second integration. That one is second integration. As the second integration, we integrate again 14. This one was x square, but now we add 1 to become 3 over 3. Okay. C1, it was C1, but now we add x, become Cx plus, we introduce this one, C2 minus 20 close bracket x minus 3 cubic. It was square. We add 1 to become cubic over 3 minus 24 close bracket x minus 5 cubic. It was square, but again we add 1 to become cubic over 3. We got this one. After integrating the second integration, we got this. Okay, this is the second integration. We got this. Now after that, now we are going to get the value of C1 and the value of C2. The value of C1, we get the value of C1 and the value of C1. How can you get the value of C1 and C1 and C2? The first thing we go to getting the value of C2. Because to get to this one is easy. How can you get the value of C2? The boundary conditions are at x equals 0, y is equal to 0, and 2 at x 6 meters and y is equal to meters. Now we substitute. The first thing we do to get this one, we substitute x is equal to 0 and y is equal to 0 in equation 2. We substitute in equation 2. Now if we substitute y is equal to 0, this one is equal to, in equation 2, what can we get? Then substitute b in equation 2, then x up by this one, this part will be 0, 0, 0, then 0, 0, then we will get c2 to be c2 will be 0. Okay, then substituting, then how can you get c1? When we want to get c1, we say x equal to 6. 6 is a span, total span. This one is total span. So we substitute 6 to equation 2. This one is equation 2. Let me see, it was question 2. Let's see. 14 over 3, 6 square. Yes, this one is question 2. Okay, we substitute this question. Now after that we get c1 to be this one, after substituting this equation to this part. Then the other thing we do, then we go to substitute c1 and c2 in equation 2. We used equation 2 to get c2 and c1. Then again, the value that we get from c1 and c2, we place them in equation 2. Okay, yes. Now substitute c1 and c2 in equation 2. We got c2 to be 0 and c1 to be this one. So now let's go to equation 2. Equation 2 is here. This is equation 2. This is equation 2. Okay, so c2 is equal to 2. It was 0. We place 0 here, and c1 was this, so we put it here. Now after placing it, we got 14 x square over 3 negative that 136.67x minus 20 over 3 close bracket x minus 3 cubic, this one. Okay, after that, deflection over beam at D. Now the question, determine the deflection at G. Now we calculate the deflection of the beam at D. We calculate the deflection at the beam at D. We calculate the deflection of beam at D. At D, the distance is 3 meters. Now let's calculate the deflection at B. The deflection is normally this way. This distance is deflection. This distance we call it deflection, and this one is slope. So this we calculate this deflection. Okay, at D. So we say x is 3 meters. Okay, then we put this x at equation 3. This equation that we got, we put it here on this equation that we got. We put it 3. Where is x? We put 3. Then we came to get what? We get this one. Then we have ey. After finding that, we have ey over ei. We were given ei, so over ei we get this one, deflection to be negative 116.7 millimeters. Now deflection of the beam at C. Okay, at D, x is equal to 5 meters. Substitute the value of x in equation 3. Now, again we substitute the way we did it here. Okay, we substitute again. They are asking for deflection at C. Okay, we substitute again. After substituting again, we get this one. Okay, deflection of B at C. At D, x equal to 5. Substitute the value of x in equation 3. Get this one. The substituting. I think this is. So let me show you how we started there. So the first thing we did, we get the reactions. So after reaction we equate the equation with general formula of EI is equal to d square y over dx square. We got this one. Okay, and we have done it here. The second thing that we did is integrating 2 times first, second, third. Reaction, equate the equation with the general formula of this one, integrating 2 times. Okay, after integrating 2 times, number 4, we do what? We look for we get values of C1 and C2. We get values of C1 and C2. Okay, get the value of C1 and C2. Number 5, we do what? After doing what, then we place the values of C1 and C2 in equation 2. We place values of C1 and C2 in equation 2. We get the values of C1 and C2 in equation 2. Okay, we place value of C1 and C2 in this place, and then we continue. So this is the procedure. Okay, so I want you to follow where we started. So this is where we started it. You can also screenshot if you like. And this is the last part. Okay, thank you for watching. Please subscribe.